Yeah. So we'll talk about ensemble of classifiers. What is the idea of ensemble of classifier? Idea is that instead of running a single classifier for a particular problem, you run the multiple classifier and you take the majority voting. Okay. So this is the basic idea of the ensemble of classifier. Okay. So here we go. That two heads are the better than the one. Okay. So when you are a bit confused, so you ask the others what should be done for a particular instances, particular problem. So in that case, you ask your many friends, and you then finally you take the decision. Similarly here, instead of taking one classifier, you ask for the same problem, you ask the multiple classifier, in that you take the majority voting. So construct a set of classifier from the adopted version of the training data. So important part is the adopted version of the training data. And then what you do it, uh, combine the prediction of the classifier in somehow. Okay, often by simple averaging or voting. So let's say if you have the 7 classifier, and then 4 classifier says this pattern is this pattern, this this object belongs to class A, then obviously you go with the majority of the classifier what it says or what they say. So this is something called the ensemble of classifier. So it has two parts, as you see, key adopted version of the training data. Please note that we have only a single training data, and from the these training data, either we will generate the different training set, either using resampling or reweighted. So based on these two criteria, we will have the two different techniques for ensemble of classifier. Okay. So we have a simple statistics here. We can see, say, okay, here we have original training data set, and what you do it from this training data set, you generate multiple training data set. So what ideally what you should do, sir, I am in a class. After some time, I am calling you. Okay. Okay. So what you do it, first step you generate the different training sample from the same training sample. Okay. How do you do it? So you use the what is called sampling with replacement. Okay. So then you do different time. So you'll get a set different number of what is called, because random sampling you are doing. So obviously, say let's say, and with replacement. So as I said in earlier, there is a chance that 66% sample will be new, and then there will be duplicate of the last of the 33% sample. There might be the probability that 33% sample will be duplicate. So having said that, what we do it now, we run the different classifier for the each individual. So consider this one is a training data set, and you run a classifier. Let's say you run the k nearest neighbor classifier. Then you run the C2 with different values of k, or you can apply the weighted KNN. Then C3 you apply the decision tree, and then C4 you apply the decision tree with different parameter. C5 you run, say, artificial neural network, and C6 you run another artificial neural network with different number of layers and different number of neurons. So then finally what you have, you will get the so many 6 model, and then what you do it. So whenever the you need to identify the class level of unknown object, so you pass the unknown object to this model number 1, and you see what is the class level. Same model, same instant, same unknown object you pass to the model C2, and you see the level. So out of the 6 one, if say 4 objects says key a particular object, 4 model says key particular object belong to a category 1 or 0. So then you take consider based on the majority voting, you decide. So class level of the unknown object is select 1 or 0. This is the basic idea of the ensemble. Okay. So hopefully you understood. So once you understand this one, then maybe today's class is over. Okay. Instead of running single classifier, you run multiple classifier, number 1. And then what do you do with multiple classifier? There may be, so one assumption is that these all classifiers should be independent to each other. Okay. So then what will happen? Say suppose if C1 make mistakes, then there is a chance that C2 will not do the same mistake because both are independent to each other. So based on this one, that ensemble of classifier is developed. So or maybe some statistics I can show you here. Suppose there are 25 base classifier. That means you have, instead of single classifier, you have now 25 classifier. And as I said that a classifier must be better than a random classifier. So classification accuracy for the random classifier is 50% and error rate is also 50%. So whenever I say is a classifier, that must be better than the random classifier. So therefore, so each base classifier should have the accuracy above 50%. So now you say is that, let's say each classifier has an error rate, that is epsilon is 0.35. That means that accuracy is above 50% and exact value is 0.65 or 65%. And assume the classes are classifier are independent, then what will happen? That probability that the ensemble classifier make wrong prediction, when it will predict the wrong prediction for which for a particular data set, a particular test data set, whenever that same test data sets will be considered as, say, will be misclassified by at least 13 base classifier, because see, if the particular instances test object will be misclassified when the out of the 25 more than 15% is, say, 13 object, at least 13 classifier must tell that they are not in the we will do the same mistake. Same mistake means if the object belongs to class A, so these at least 13 classifiers will tell that this object does not belong to class A, so it may be other than A. So that means they will be doing the mistake is 0.35. Now what will be the probability, that ensemble probability that it will make wrong prediction? So here we go. What is this one? Epsilon is the probability. Epsilon is the classification error rate for single object. So therefore epsilon I, and then what is the right choice for the other classifier? So it will be 1 minus epsilon. Okay, because one classifier is not doing mistake means it is rightly predicting, and then prediction that error right prediction is 0.65. So this is nothing but the 1 minus epsilon. Now when it will be wrong, so if at least 13 classifier says wrong, says key these are the 13 classifier misclassified, 13 classifier wrongly misclassified, so then only this part will be wrong. So therefore, so this I will start from 13. Okay, and then for all cases this will be the wrong, at least 13 classifiers should wrongly misclassified the object, then only we will say there is error. So now if you compute it, so it will come down the error 0.06. So what is the interesting thing you need to observe? So if you apply a single classifier, error rate is 0.35. But whereas if you apply so more than one classifier, in this example 25 classifier, then error rate will drastically reduce to 0.06. So here accuracy, how much accuracy is 0.65? Here you see the accuracy is 0.94. So therefore, ensemble classifier should work much better than the individual classifier. Okay.
Sir.
Yes.
Sir, each of the classifiers are taking the entire data or just a sampled fraction of the original data set?
So each of the classifier, let's say you have the training data set is 100 points. Okay. Okay.
Yeah.
You have training data set 100 points. Now you generate a training data set with 100 points, but you use the resampling technique. You use the replacement technique, okay, or sampling you use with replacement. Okay. So therefore, when you will get the data size will remain 6. That is, you will have the 100 data. Okay. But because you are using the replacement policies, so therefore you will have the many duplicate data, and that probability is that 33% data will be duplicate. So you will have the 66% data will be the there is no there won't be any duplicate for the 66% of the objects. Okay.
Okay. Okay.
So now again you go for developing the another training data set, and you use the same technique. Okay. So now you have the two training data set, and then you apply the two different classifier on the top of the two different training data set. The two models, and these two models will be used for predicting the class level of the unknown object. So each unknown object will pass these two model, and then you will take the majority voting. Here is only, say, let's say instead of taking majority voting, but you can say whenever the object both says is yes, yes, then you consider that is the right classification, otherwise you reject it. Okay. Or no, no, you consider it. If it is both is 1-1, then you say ki, I cannot, this model cannot identify the class level of this object. Okay. So this is the basic idea of the ensemble of classifier. In the next 5 to 6 minutes, what I do it, I will show it one example, and that will I will end the class for today. Okay. So here we go. What is that? So training set D and a learning algorithm A, and T is the ensemble size. What do you do? Ensemble of classifier will be the output. For T equal to 1 to capital T, T is like, say I want to make the ensemble of 10 classifier. So what you do it, build a bootstrap sample dt by sampling D points. That means out of 100, you use the sampling technique with replacement. So you will get a data set, so that is called delta D. Now you run A on dt to build a classifier empty. So you run a classifier. So please note that you should take a classifier which has the accuracy is above 50%. If any classifier accuracy is below 50%, you cannot take that classifier. Otherwise, you need to change. You need to change this one. You need to change the data set. Okay. So run A on dt to build a classifier and return finally all set of the model. So it is the same thing I wrote in a different way. So this strategy, whenever you are just emphasizing only on the you are using the data, that is training data using replacement technique. So that is something called the bagging, bootstrap aggregating. That is something called bagging. Now what I do it, I will show one example of the bagging technique here. This is the simplest example, but you will see so beautiful the simplest example is. So we have a data set that is a one-dimensional data x. Okay. So x is the different value, and then y is the class level of that particular value. So that means this is nothing but the set of points on a one-dimensional line. Okay. Now what do you do it? So on real line, you have a set of points. So this class level is 1, this class level is 1, 0.3, class level is 1, and so on. Now what is the task? Task is that if you use a single stump, this decision stump, this is something called a decision stump. That means I will identify value of x. If x is 0.4 greater than 0.4, so then I will say it is a negative class, or 0.4 less than equal to, it will be a positive class. Essentially what I am trying to say is I will find a value of x which basically the classification line, that is decision boundary or decision line. So that is something called decision stump. Okay, STMP. So decision stump, which essentially only the value of x will say. Say let's say I say ki if value of x is lesser than 3, lesser than equal to 3, it is a positive class, otherwise it is a negative class. So this is one decision stump. Now in this example, did you get my point? This is very important. What is decision stump? You need to know. Decision stump is, say, suppose if you plot this one with x and y. Say suppose you are plotting x on the real line, and then y is the another. Say this y value is categorical value. You cannot plot it over x and y. So x and y 2D Euclidean space. This is nothing but you have a real line x. Okay, and then if the value you count from the 0 to 0.1, So this is 0.1 and then 0.2, 0.3 and so on. And it has the class level. So suppose this is on one object. 0.1 is a value and it has a class level and class level is 1. So now what you want to do, I need to find a decision term which can segregate the positive class and negative class. Okay. So in this example, I can say I have a decision term and decision classifier is x greater than less than equal to 3. So that is positive class and above is negative class. So someone can tell I have a classifier which is 0.75, x 0.75 lesser than 0.75 is negative class and above this one is a positive class. Okay. So now in this example, you cannot find a single decision term which can rightly the class level of the each instances. That means there are 10 objects and you cannot find a single decision term which can identify the all training object rightly. This is something quite is XOR problem. We also said you cannot find a single line which can identify the all points with right classification. Here I say the same thing. You cannot find a decision term which will identify the class level of the all objects. So if you understand, then only I'll proceed. Otherwise, again, I have to use board and so on. But rest of the thing is without board, I can do it.
Hello, sir.
Yes.
Can you just give a quick repeat of bagging? That
So bagging is something like that. So bagging is okay. Where is so bagging is here. Bagging is that how you generate the training data set. If you use the sampling technique with replacements, that is called the bagging. Okay. Rest of the thing is same thing. Once you have the different training data set, you apply the different classification technique. So that is something bagging why it says you are developing the training data set with replacement. So that technique is called bootstrap. That is why it is called bagging. But what I want you to concentrate on this part, then rest of the thing will be automatically you will understand. So did you understand what I said? You have it. So let's say you have a training data set here. You have a X and Y. Can you see the slide? I don't know the slide number. It's bagging example. X and Y, 0.1,
yes, sir,
0.2.
yes, visible.
You can see. So now my point is here. So what if I draw it here? Where is the line? Insert. Okay, let us see. I should get somewhere line. Where is the line?
सर शेप्स के अंदर है
हाँ?
शेप्स वही इंसर्ट के अंदर
Then where is shape?
क्लिप आर्ट के राइट साइड में
Shape, yeah. So suppose this is the line, right? So this should be it should be how do I make it thicker? So can you see the line?
Yes, sir.
Yeah. So now what you have to do is, let's say this is the value of X and this is, okay, I can draw a line. Yeah, this is the line, let's say, this is the line. So now you plot the value. So let's say this is 0.1, this is 1 point here, okay. So next you have another value 0.1, 0.2. So this is another 0.2. So this class level, you write it here. Say this class level is class 1. This class level is also class 1. Okay, class 1 and so on. Okay. So now what you have to do, you have to find a value of X. That means essentially what you have to do it. So what is the insert? Let us try shape. Yeah. So what you have to do, you have to find a line here. Okay, you have to find a line. So I will say ki lesser than this one is having positive class, and on this side will be the negative class. So I will say ki this side will be say negative class, and this side will be positive class, and then value of this line is this line not equation. So this is something called, let's say, value of x equal to 0.75. so this is 0 x equal to 0.75. so that is I am saying the decision stump. Okay, so now what you do it, you cannot find a single decision stump which can identify rightly the class level of the all object. Now we go back here. That is the case. So you got the decision stump. I said ki you can have a multiple decision stump, but a single decision stump cannot identify the class level of the object. Now, what will show it, if you use the bagging technique, that means if you use the bagging technique, multiple classifier, we can rightly classify the each object in the training data set. Here we go. So what do you do it? First, we use the bootstrapping technique. That means out of these 10 objects, randomly we choose some of the object 10 times. So then first time you got 0.1, second time you got, say, let's say 0.2, second time also you got 0.2, third time you also got 0.2, because it is like you are picking the point with replacement strategy, random replacement strategy. So there is a high chance that you can get again 0.2. Similarly 0.3, then 0.4, 0.4, 0.5, 0.6, 0.6, 0.9, so on. So there are 10 objects and there is duplicate. Now what you do it, you know the class level of 0.1 is 1, you note down, 0.2 is 1, 0.2 obviously it will be 1, 0.3 is 1, minus 1, minus 1, minus 1, and so on. Now what you do it, this data is different, this data is different. Now what you do it, you find a decision stump which can rightly identify the class level of the all objects, but that might be difficult. So what you have to do, you find a decision stump which will minimize the error. So what you can do it, you can have a decision stump here, then how many object will rightly identify, this will be positive, this one also will be positive, so these two will be wrongly identified. So you cannot keep the decision stump here. So this is, if you say is negative, then this will be wrong. If you say positive, so this will be wrong. So that error will be minimized if you take the a decision stump of something like that, x less than equal to 0.35 will be positive, otherwise it is negative. Did
Sir,
you get
zero
this
point
part?
two. Sir,
Huh?
0.2 repeat twice. This is
0.
right to repeat twice.
No. See, you have a, this is the decision. This is a what is called is the training data set. Forget this one. From here we got a different training data set. Now what you have to do? You have to identify the class level. This is a training data set. So you have to make a decision stump which will eventually give the least training error. Okay. What is the training error? Once you have the decision stump, again you classify the each sample. So therefore, what you do it, you take, so above 0.3, so some value you take 0.35. So above 0.35, you consider as all negative class, and below is positive class. So below is positive class means is rightly identified, and above this one is what? These two will be doing mistakes, right? See, these two will not be identified rightly. So therefore, so if you use some other place, so instead of 0.35, you are free to take any other part. So let's say here 0.65. 0.65 above is positive and below is negative. If you do this one, then for these 4 objects, you will get the wrong result. So therefore, earlier you are getting for 2 objects, now you are getting for the 4 objects. So I said ki you find a decision stump which will give the least error. So therefore, you x less than equal to 0.35 is a decision stump. Class level will be positive 1 if it is lesser than, otherwise it will be minus 1. Did you understand this part? You need to understand this part, otherwise I cannot move the next part, and next part is part.
Sir, what happens if all the bootstrapping data sets are like duplicate of some one data set?
Then you use same technique.
Sir, and if classifiers shown like different classes for same data set, same duplicate data set.
I have example you can see, but for instance, I am giving. You are saying ki all is coming 0.1, right?
Yes, sir.
So then, what will be the class level? All will be 1.
Yes, sir.
So decision stamp you take is above 0.05 is all positive class, below is negative class. So you find another decision stamp for that. Got my point?
Yes, sir. Yes, sir. Yes,
So
sir.
you will see the example if you proceed next. So next, this is say first round. First round means we got a training data set and we got a decision stamp. So now in the second one, so you got another decision, what is called a training data set using same sampling with the replacement technique. So you have taken first one 0.1,
Sir, if both sides equal,
huh?
sir, if both sides equal error, then what can do?
Which one is equal or you both side means wherever, then you can take that is also a decision tree. What is there? You can take any one of them. You got my point. So I'll show you actually that is
Yes, sir.
so let's say you have another training data set you got after sampling here. Now and obviously whenever 0.1 always it will be 1 because I am getting from the original data set. 0.5 it is -1, it must be -1. Now you have a training data set. Now what is the task? You find a decision stump. You find a decision stump where the error will be minimum. So if you do it, so here in example, if you take the 0.65, 0.65 is somewhere here, right? So if lesser than 0.65 is positive and above also is positive. Okay. So the lesser than 0.65 is positive and above also positive, then we'll get the error is what? For these 2 points we'll get the error. Okay. Again you can say is here above 0.05 is all positive class. Then also you will get the same positive two error. That is you said, someone said just few minutes before, right? So if you same error, either you can take 0.05 or otherwise you can take 0.65. You got my point? Let's say you put a decision term in between decisions stump in between 0.5 and 0.6, 0.8. So let's say 0.65. So here is positive and below is also positive. But in these two cases also will be there is a problem. Now instead of that, what you can do it below 1.1 is all positive class. That also is correct. So you will get the two error. So essentially what you do for no decision stem can find the 100% error for even this data set also. Okay. So that is not the question. Question is originally this data set you cannot find a single decision stem. Now you go for the third round bagging. So in case of the third round bagging, you got the data set is like that. So now you find a decision stamp which error will be minimum. So let's say here we got it 0.35. So you take a decision stamp here, lesser than is +1 and above that is +1. And three cases you'll be doing the mistake. You can take here also. What is that? 0.7. If you take 0.7 or something like that, so 0 above say 7.5. Above 7.5 is somewhere here. So then 0.75 is error is -1. 0 point is 1. Class level is 0.8 is 1. So therefore, you'll get a decision stamp here. Are you following me? Or I am going fast? Chinmoy?
Sir, if we take the decision step at 0.75, in between the two 0.7, so we have to take like after 0.7 and before 0.8, so there will be one error then.
See, this 0.7 is actually is wrongly written. This should be -1. This -1 is moving here.
Yes, sir. Yes, sir.
Yes, actually original value is minus. See, I wrote in a LaTeX. So this minus somehow it came here. So you want to say ki you take 5. 5 is this is positive and here all are negative, you are saying.
Yes, sir.
But in that case, these 3 will be wrong, no?
Wrong. Yes, sir. Yes, sir.
This is wrongly mentioned. Okay, this is that it should be -1 here because original is -1. Okay.
Yes, sir.
So you have to find a decision stamp which will give you the minimum error. So that is the model. Okay. Now you go for the another bagging technique. So you got this one and you find the bagging values is x less than equal to 0.3 is positive, otherwise negative. X less than equal to 0.8 is somewhere here. So it is positive plus, rest is negative plus, but these 3 will do mistake, right? So next you go for another bagging technique. So now here you see it is almost same as this one, right? But may not be the 0.1, 0. No, data set is different, right? 0.1, 0.1. But here if you take this one somewhere here, so x lesser than 0.35 is positive, otherwise negative, but these 3 will do the mistake, okay? Similarly, you get the bagging round 6, 7, 8. So somewhere bagging 10, okay? You get 0.1, 0.1, 0.1, 0.3, 0.3, 0.8 and all class level is 1. Essentially someone asked if the same data is repeatedly coming. So it is maybe the all class level. Now what do you do it? Either you can take lesser than 1 is positive class, or you can say above this one is positive class. So that is x lesser than 0.05 is x lesser than 0.05 is negative class. So this side is negative and above this one is positive. So this is another decision stamp. Do you have any doubt?
So how many rounds do we have to search for?
No. This is the one example. So this is one example I am saying I am doing 10 rounds. Okay. So it depends on how many classifier you will apply. So in a particular problem, say if I want to apply 10 different classifier, obviously you should have a 10 data set, and that is something called round. Okay. So in this example, but what is the conclusion? Conclusion is that if you have a 10 decision stamp, no decision stamp can identify original data set. Now what will happen? So let's say this is a decision stamp for this training data set, you got it. Now what you do, using this decision stamp, you identify the class level of the original data set. So what is the decision stamp? Decision stamp is 0.75. You move 0.75 here. So can you identify what is the class level for 0.75? It is lesser than -1 and above is +1. So lesser than 0.75 all should be -1, but unfortunately this will do the mistake and above will do the right thing, but this will do the mistake. So therefore, what we can show you for no decision stamp, rightly identify the class level of the original training example. Okay, that means no decision stamp will have the training error 0. Did you get my point? So once, see this, what essentially what we did, we have the training data set, we make a model. Now what you do it, you throw this model. So all this model you throw it. So you data set this training data set, you throw it, you keep the model. What is the model here? Model is x less than equal to 0.35. This another model x equal to 0 less than equal to 0.65. Another model is x lesser than equal to 0.35 is positive and otherwise it is negative class. Okay, so now what you do it, no decision stamp can identify the zero training error, will not give zero training error, but if we combine this 10 decision stamp, then we will get the zero training error. That is, we'll show in the next slide. So here we go. What is that? Original training data is this one. There is no change. 0.7 was -1, so I kept -1. Now what you do it? You write the all decision stamp here. So first decision stamp was x 0.35 will be positive, otherwise it is negative. Now you have the training data set here. What do you do it? If lesser than 0.35, all be positive and rest will be identified as a negative class. You got my point? Okay, so you identify it as negative class. Similarly, 0.65 greater than equal to positive, lesser than equal to also positive, it seems. So then all will be positive here. So this one is lesser than equal to 0.3 is positive, or otherwise it is negative. So here up to this one will be positive class, rest will be the negative. Similarly, lesser than 0.3 will be positive. So lesser than 0.3 will be positive, or all will be negative. Similarly, 0.75, 0.75 you wrote many times. So 0.75 for the 8th sample, it's okay. You can see bagging at x lesser than equal to 0.75. So this is the model. Now you forget the original, that is the sample training data set. You forget. You have the original training data set, and that you identify the class level. That is the task. You have to identify the class level of the original. That you should get the training error 0. So that is 0.75. So lesser than equal to 0.75 will be -1. So therefore -1, -1, -1, -1, -1 up to this one. Above this one is positive. So you have to keep all positive. So last one, what we said is, this is the decision stump. What will be the decision stump? If lesser than 0.05 will be -1, otherwise all positive. So therefore, what will happen? So it will give the all positive here, because lesser than 0.5 is no training data. So it will identify all as a positive class. Got it?
Yes, sir. Yes, sir.
Yes, sir.
Very good. Now what you have to do, you have to take the majority voting. So among this one, out of the 10, how many objects, how many times they are saying is positive class? Positive class is 1, 2, 3, 4, 5, 6. And the negative class is 1, 2, 3, 4. So therefore, what will be the class level? Class level will be 1. So essentially it is the same thing. What you do if you add it? If it is positive, then you write is 1. If it is negative, you write the -1. That is negative class. For here, so what will be you pass this object to the all 10 model. So that model is here. That is the decision stump. Okay. I think stump spelling I said wrong. STUMP. Okay. So then is 0.2. What you do it? 1, 2, 3, 4, 5. So 5, and then this is 6, and then minus is 4. So therefore you will get the majority class is saying positive class. So therefore class level is 1. It is essentially same thing if you add it. Okay. Here if you add it, so if you see here 1, 2, 3, 4, 5, 6, 7, 8, right? 8 minus 8 plus 2. Okay. So therefore you will get -6. Okay. -6 means if it is negative, so you write -1. Now this is the class level combining the all decision stump. This is the class level. And what is the actual? Actual is 1. You write it here. Actual is 1. Actual is 1. -1, -1, -7 is -1, and so on. So you see, individual decision stamp cannot identify the original dataset rightly. However, if you take the combination, that class level is matching. So therefore, if you combine the classifier, it will obviously give the better result.
So if we get the same number of +1 and -1, then it will be 0.
So, so in that case, you can say you cannot identify the class level of that particular object, because majority
Okay,
voting
sir.
is not applicable. It is like hang, okay, hang parliament, like 0, you cannot take a decision. So you can simply leave. The system cannot give you the class level for this object.
Sir, when you talked about ensemble of classifiers, there the training set, like we were applying different classifiers to the like parts of the training set and then combining them. But here
Yeah.
we didn't do like that way.
Which one we didn't do?
So in bagging, the example you showed, like we created duplicates of the training data set size data, and then we used the same type of classifier in all the models, right?
Decision stump.
Yeah, decision stamp, but okay, when we say that different classifier, it could be, it's not necessarily that different algorithms.
Yes, yes. But obviously it will be good if you take the different algorithm. Otherwise, what you can do it, say you can use k nearest neighbor with different values of k.
Okay, sir.
Okay, decision
Yes.
tree you can use with different values of different. I will show you after this slide that there is something called the random forest. We had the what is called is decision tree. In the next slide, I will show you the random forest. But before that, you need to understand the basic idea of ensemble of classifier. Random forest is nothing but a slide, and that is sufficient to understand the basic concept. Okay. Here is, see, I didn't take the duplicate. It is like randomly you are picking the points, and because there is a chance that duplicate, it is a random sampling with replacement, so obviously duplicate will come. Okay.
Yes, sir. Yes, sir.
So if you understood rightly, now I have only one slide. Okay. So it is something called random forest. So bagging is useful is the combination with the decision tree. What you do it, build each tree from a different random subset of the features. Now it is little different from earlier. What is that? Build a bootstrap sample by sampling with replacement. So that is the same as the earlier one. Now what you do it? Suppose you have 100 features. So out of the 100 features, you take only 5 features and you build a decision tree. And your selection will be, these 5 will be random. So select D features randomly and reduce the dimensionality of DT accordingly. Obviously, say let's say you have a data set 100 points and then 100 samples. Sorry, 100 sample and you have this 30 features. So now what you do, out of the 30 features, you take only 5 features. That means you take the 100 instances, but you take only 5 features of those instances. So using that one, you make a decision tree. Okay. Similarly, again you take the different bootstrap sample, okay, and then you apply the another decision tree, and you pick another 5 different features for making the decision tree. You have a multiple decision tree, and each decision tree is built over subset of the features, not the original all features. Okay. And then you combine these results here. So whenever the new objects come, what do you do it? So let's say new object will have also 30 features. So now you identified which 5 feature was used for building the first model. So you pick that 5 features and you feed to the first model and then identify the class level. Now again you take the same test instances and you feed to the second model. Second model is again built over another 5 features, or maybe there may be overlap. So again you feed those 5 features to the second model and you get the results. So therefore, if you have the 10 different random sample, 10 decision tree, you will get 10 different results and then you combine them. Okay. You have any question? Hello.
Sir, are there any backsides of increasing the number of classifiers? Like, can we expect always the accuracy will always increase with the increasing number of classifiers?
Yeah, it is proven that if the classifier are sufficiently independent to each other, then the accuracy will definitely improve. Okay.
Okay.
Let's say what happened in many times in during exam, you are good in mathematics, but you are not very good in some other subject. So you ask your friend, you study another subject, and then you finally you combine, sit together, and then solve the problem or something like that. Similarly here, in while identify the class level of the object, say one classifier is good for in particular direction, so another classifier, because I said the independent. So if you take the same type of, say, let's say someone is good in mathematics and you are also taking your friend as also mathematics, then the other paper will be might be you might be the weak. Similarly here, because independent, so it is very likely that one classifier is doing mistake in some region, so other classifier will come and then recover that region. So that is the basic idea, and it is proven if they are sufficiently independent. So then then classifier will give the better result with compared to if you use the single classifier.
Okay, sir.
By the way, I have to take some class test. Okay. So now I have to decide when should I take the class test, because I think you know that exam for you guys for this year, right?
Yes, sir.
Yes, sir.
But when you come back in summer, you have to give 2 exams. Okay. But I will take the test for the TMR. Okay. Therefore, I will fix some date for it.